Now let's revisit the problem of finding tangent planes for a given surface at a given point. Suppose our surface was given by r of uv is equal to x of uv, comma, y of uv, comma, z of uv. Now we'd like to find two tangent vectors. To find these two tangent vectors, we'll use two obvious curves through this plane. One will be where we take the u cross sections. Another will be where we take the v cross sections. So let's take cu to be the u fixed curve. Suppose we wanted to find the point, or the tangent at the point P0, which I'm going to call u0, v0. That's important. So cu will be the curve through this point P0 intersecting this surface. So that will be precisely r of u0, v, and similarly cv will be the curve u v0. Now we'd like to find the tangent vectors for these guys. So let's let r u be the derivative of r with respect to u at the point v naught. So this is the derivative along the curve cv. Now similarly, let's let rv be partial v of u0 v. Now that we've had these 2 points, we can take their cross product to get the normal vector. So a normal vector is ru cross rv. Now as long as this is non-zero, we should be good. Since this is a very important topic, we have a special name for these types of surfaces, or parametrizations. So a parametrization is smooth if this ru cross rv is never equal to 0. So to summarize, a parametrization of a tangent plane for a given surface S I should say smooth surface is of S and T. I'm going to use S and T for my parameters here since we've already used U and V, is the vector 0 to P naught plus S times the vector R U plus T times the vector R V. Let's do an example. Find a tangent plane of R U V equals U squared minus V squared I'm running out of room, Brian. Help. U plus V. And I've run out of room. U squared plus 3V. At the point 3, 1, 1. Now the first thing you have to do is find out what U0 and V0 is. With a little algebra or some guess and check, you can find that if we let U0 equal 2 and V0 equal -1, that R of 2 minus 1 will give us this point. So those are perfectly fine U0, Z0, V0. Okay, so now all we have to do is compute partial derivatives. So we want the partial of R with respect to U, and that is 2U, 1, 2U. And similarly, the partial of R with respect to V is minus 2V, 1, 3. So our RV, which is partial RV, evaluated at so RV is the evaluation of the partial of R with respect to V evaluated at U0, V0. So we have RV is 4, 1, 4. And similarly, RV should be U, is 2, 1, 3. So now we have the point and these two RU, VU. So our parametrization T at the point 3, 1, 1 of S and T is our point 3, 1, 1 plus S times 4, 1, 4 plus T times 2, 1, 3. Or we can add this all together, have 3 plus 4S plus 2T, comma, 1 plus S plus T, comma, 1 plus 4S plus 3T. So that's it for this example, Brian.